Hi friends, welcome back to another session of EC Made Easy. Now, after looking at the basics of amplifiers, let us see the various types of amplifiers. Basically, we have two types of amplifiers. One is a voltage amplifier, and other one is a power amplifier. In reality, the amplifier is meant to drive the output load that needs a large power. So, in reality, we are indeed in requirement of a power amplifier, but directly it is not possible to get the output power as much required. The basic reason maybe the one is the input source, maybe a sensor or an antenna that produces input for our system, and this input will be very weak in power, and to ensure that the signal is maintained, so the only option is to make sure that no current drain, because once you say current, that means there will be uh, expenditure of energy, and because of which the input available, which already weak in power, may just disappear. So to ensure that no current drain from the input source is done, then only option is to avoid anything kinetic, that is a current. So only option is work with potential energy. Work with the potential energy of the signal. So that means whatever source we have, and this source is producing a weak powered signal, and this we need to raise its level so that it can be usable. So first thing is to amplify it, and while amplifying, one thing we should ensure is that only the voltage part should be taken to amplify, not any current. So that means looking from this side, we should have a very high impedance. So this amplifier should provide a very high impedance to this circuit, so that it will not allow current to flow. When there is no flow of current, then definitely only voltage will remain, and this voltage has to be amplified. A small voltage available at the input should be made very large voltage. So this way we can ensure that the signal is maintained, and but the problem is here only the voltage gets amplified, and we are not sure what is the status of the current. And if you want a high power, then both voltage as well as current should be available. Now we have a sufficiently large voltage signal, and this can further be amplified using a power amplifier, and then we connect it to our load. So that is one reason why we need two types of amplifiers. The other reason is the power. When you want a maximum power at the output, then we need to ensure that maximum power transfer theorem is applicable. And the maximum power transfer theorem says that whenever two systems are being connected, then the output impedance of the first stage should be the complex conjugate of the input impedance of the second stage. So this output side, this input side impedances must be complex conjugate of each other, and same thing, this output impedance of the power amplifier should be complex conjugate of the load. Therefore, the whole design depends upon the load. So we need to first understand what is our load, and then accordingly the amplifier should be designed with appropriate output impedance. And then looking at this side, we have a voltage amplifier. Its output impedance should be considered, and its complex conjugate should be used at our input of power amplifier. And that way we need to design two different types of amplifiers so that the whole system works more efficiently. More details to follow. So, till then, take care. See you. Bye.